Okay, we're going to get you started looking at some problems that involve half-life today. And just a quick background of half-life. Half-life is the idea in science that you have a certain amount of substance today, and certain substances decay at a given rate. And half-life then, I'll just make up some numbers here. Let's say we have 4 grams of substance today. We know the half-life of the substance is, say, 20 minutes. Well, what that means that after 20 minutes have passed, this 4 grams of substance has actually turned into 2 grams of substance. Okay? Now, what happens if another 20 minutes passes? Well, that 2 grams of substance hasn't gone away, but it's turned into 1 gram of substance. Well, so after 40 minutes, you have 1 gram. After 60 minutes, you would have a half a gram. Okay, so every time you have 20 minutes time frames going by, you get rid of half of the stuff. Okay, we're going to turn to our calculator and do some problems here in a little bit that require us to work with half-life. Now, the good news is the formulas we have put in the other day into Y8. So the formula we will use today to accomplish our task is to go to Y8 in the solver. Okay? So we'll do that on the next screen anyway. I'll show you everything you need to know there. Okay, so what we'll do is I'll go through each and every one of these, but please don't watch this entire video unless you need to. This video will be put up on Classroom, and you can use it as you need so that you're not just following along as I do all of these. Okay? The first one, though, we better go through a couple of these together, I guess, to get started. First of all, you should have, in your calculator, we should have the ability to go to the solver. So let me quit out of here like we are. Let's go to the solver, which is under Math. Okay. And pushing Math, and then I'm going to go to down until I get to the solver, which is down here. It might be numbered differently on different calculators. On this particular one, it's B. And push Enter. Now, whatever we were doing last time with the solver, we may not want to use here. In fact, we want to use Y8, so I'm just going to treat it like it wasn't there. Arrow up and push Clear. And then we want Y8 to be in there, so we're going to say vars, yvars, function, and then just go get Y8. Now, nothing fancy there, except we've hidden a formula in our calculator in Y8 that we can use in the solver now to solve half-life problems. So I'm going to arrow down. The variable y, n, k, and t show up. Y stands for the amount of stuff that we have at some other time but right now. Okay? So this is an amount of substance not right now. N stands for the amount of substance we have right now. Today, this moment, right now, this is an amount of substance now. Easy to remember with the N. K stands for a constant of variation. Now, constant, you probably don't think of spelling constant with a K, but we'll think of it that way, that constant is K. K is really irrelevant to me, except it's so important that we have to find it first before we actually answer the question intended. So this will be important to find first, but we really won't care what it is. Okay? And T is time, and we'll mess around with that as we read the problems here. So as we look at this problem, it says the half-life of an element is 950 years. What that means is that the time is 950 for a certain amount of substance that we start with right now to turn into half as much. So I'm going to go ahead and leave this relationship right here. 950 years half-life means that 2 grams, let's say, will turn into 1 gram. This could have been 4, and then this could have been 2. Or we could have said 10 and 5. You must have a built-in half relationship here, n being the bigger amount, y being the decayed amount, for you to be talking about half-life. Notice then we've got 3 of the 4 variables filled in, so now I can just simply move my cursor to the k and hit alpha and enter, and that solves. So this is the constant of variation for this problem. Now, I don't care what that is. Don't write it down or anything like that. We just know we have to find that first. Now, It says how much will remain 125 years from now. Now that we know the constant for this problem, we can go change the time to 125 years and enter the amount. Now, they said, was 45.6 grams. So the 2 and 1 just played the role of establishing a K. But now we have actually 45.6 grams today, and we want to know how much we will have in 125 years. So I can alpha solve on the Y. And the answer is 41.63 grams. Okay? That is number 1. If you feel confident in moving forward, do so. Pause this. If you think you need a little bit more help on this particular one or on the next one, push play. I'm going to keep going. Oh, okay. You would not necessarily have to do this, but I've entered 5s for all of these values so that you don't get confused about what is left over from the last problem and what is left over, or what we're putting into this new problem. So I've just changed these all to 5s. Don't put them as zeros. Zeros sometimes cause difficulty with the solver, so if you can avoid zeros, great. But I just entered these all as 5s. Now we'll read the problem. It says the half-life of an element is 4,560 years. What that means is that the time is 4,560 years for a certain amount of substance to be turned into half as much of that substance. So the now amount, let's make that a number easy divisible by 2. Let's call it 2. Half as much of 2 is 1. So in 4,560 years, we're going to turn 2 grams into 1 gram. That's enough information to solve for a K. Okay, I'm glad that did that. If it gives me an error or bad guess, I'm going to push the number 2 to go to it. It's basically telling me that the K is negative because when I had it as a positive, it didn't like that. So let's make K negative and then just resolve on top of K, alpha solve. And now you see that it actually was able to do it. Sometimes if you're on the wrong side of 0 for the particular values of K, it will give you an error bad guess. So if you went to a negative, it had no trouble finding it, but while it was a positive, it couldn't get there. Okay? So then we read on. It says, if you have 36.92 grams today, so 36.92 is the amount I have today, how much was present in the sample 2,000 years ago? Well, 2,000 years ago is a negative time. It's in the past. So let's go with time as negative 2,000. And let's go back up here to the Y and figure out how much was there then. Remember, N is the amount now, like today, and Y is the amount at some other time, being 2,000 years ago. Alpha solve. So 2,000 years ago, there was 50.04 grams. Okay, so number 3 here. A substance is massed and determined to mass 25.59 grams. 63 days later, the mass is determined to be 18.47 grams. What is the half-life of the substance? Here's a change. We don't know the half-life, so we can't put 2 and 1 in and claim that we do. Instead, what we're going to do is we are going to realize that it says today you have 25.59. 63 would be a time to turn it into 18.47. So we could figure out the proper K by going to our calculator. Let me again make these, well, we learned something last time. Let's make these negative 5s. Okay? I think we learned that the K value is going to be negative. A substance is massed and determined to be 25.59 grams, and I assume that's today, 25.59. 63 days later, that's time, 63 days later, it is massed and determined to be 18.47. Well, 18.47 is the amount we would have in 63 days. Okay? That's enough information, having this now amount, the later amount, and the time it takes to get there. That's enough information to solve for K. Alpha solve. Now it says, what is the half-life of the substance? So how long does it take to turn 2 into 1, or 4 into 2, or 10 into 5, or whatever your favorite half is? How long does it take to turn 2 into 1? Question, alpha solve on the T. It'll take 133.93 days for this to disintegrate or deteriorate to half as much. Okay, so again, if you get confused about what numbers were there from the last problem and this one, just change all those again to some value other than 0. The half-life of an element is 14.3 seconds. 14.3 is the time it takes 2 grams to turn into 1, since it said it was half-life. If you have, first of all, we got to solve for the K. Once you have all 3 of the 4 pieces of information, we want to establish K. Okay. If you have 1,295 grams now, how much will remain 3 minutes from now? Okay. So I want to go now amount is 1,295, and the time is 3 minutes. Now be very careful entering this, because 3 minutes is not the same label as what we went in with 14.3 seconds. So we have to figure out how many seconds are in a minute, and you don't even have to do the math if you don't want to. Just keeping in mind, because I know you could do this one, but if you didn't know what 3 times 60 was, you can put it right in that line and see it does the math there for you. So we can now go to the amount in the future, the y value, and alpha solve, and find out that there's really not much left. And that kind of makes sense if you think about it, because 14.3 seconds, half goes away. 14.3 seconds later, another half goes away. Well, how many 14.3 seconds are there in 180 seconds? That's a lot of halves. So you've cut 1295 in half and in half and in half and in half and in half. And so, yeah, you get down to not very much stuff. Okay? It seems reasonable anyway. Okay, number 5. The half-life of a substance is 45.9 days. Since I know it's the half-life, I know I'm going to turn 2 grams into 1 gram in about 45.9 days. That's enough information to establish the K. Once K is established, we can move on towards the answer of the question. If you have 30.62 grams at this time, how much will remain in 12 days? 30.62 grams is a nice amount now. And how much will be there in 12 days? Time is 12. Solve for the amount at another time besides now. Solve for the y. The answer is 25.54 grams. Okay, let's put these in as just some constant. Okay. 25 days ago, the mass of a sample was 345.89 grams. Today, the mass of the sample is 245.98 grams. What is the half-life of this element? Okay, so since we don't know the half-life, we can't put 2 and 1 in the y and n yet. Okay, we need to establish K, and the 3 things that we're going to put in need to be related. And so it says today we have, so the now amount is 245.98. The amount at some other time besides now. Okay, number 6. 25 days ago, the mass of a sample was 345.89 grams. Today, the mass of the sample is 245.98 grams. What is the half-life of this element? So what we need to do is read that right now. Okay, I think the 3 things we know are the amount now, the amount in 25 days, and the fact that the time was 25 days. That would establish K. Okay, so 25 days ago, the mass of the sample was 345.89. Today, the mass is 245.98. So go to the now amount and make it 245.98. Go to the not now amount and make it 345.89. And the time it took to get there was 25 days ago, so a negative 25. And we kind of realized that whenever the y amount is more than the now amount, you're going back in time. So that's enough to establish K. And I'm thinking maybe K might have a problem here with -5. No, it worked. Okay. So we've established K, and then it says, what is the half-life of this element? So the question is, how much time will it take to turn 2 into 1, or again, 4 into 2, or 10 into 5, or 100 into 50? You pick your favorite half relationship here, but remember n is the amount now, so we want that to be more. Y is the amount later, we want it to decay to less. And so the time it takes would be 50.84 days. Okay, so number 7. An isotope of carbon has a half-life of 5,730 years. If a sample contains 4.508 grams of carbon today, how many years ago did the sample contain 7.24 grams of carbon? Okay. It says an isotope of carbon has a half-life of 5,730 years, which tells me I know the time it takes 2 to turn into 1, and that time is 5,730 years. That's enough information to establish K. Once K is established, if the sample contains 4.508 grams of carbon today, okay, that's a now amount, 4.508 grams of carbon today, how many years ago did the sample contain 7.24 grams? 7.24 would be an amount at some other time besides today, and I bet if we solve for t, it's going to be negative because it said years ago. Let's solve for t. And the negative just means it's in the past, and we realize that to turn an amount now into more would have to be backwards if it's a decay, if it's like a half-life. So negative 3,916.47 years is 3,916 years ago. All right, for the most part on this back page here, I'm going to just let you guys try and do your best here and see if you understand half-life and how the solver works. We can talk more about this on Monday when I'm back. If you realize here, I just want to touch up on one thing, and that is how to get back and forth between those other formulas. So, for example, I approach problem 9. It says find the time required for 1,000 to double if invested at 5.25% interest compounded quarterly. What you know is this isn't half-life, and see I'm in Y8 currently, so that's the wrong formula for this one. So let's clear that out. And if you remember, compounded a certain number of times, quarterly meaning n is 4, we need the formula with an n in it. We need Y9. Y0 is for compounded continuously. So let's go vars. Oh, I should actually, let me back up here. I'll show you exactly. I realized you aren't seeing my keys. Okay. Let's go, here we go. Let's go vars, and let's go y vars, and let's go function. And Y8 is for half-life. Y9 is for compounded a certain number of times, money problems, interest problems. And Y0 we put in there is for compounded continuously. So let's go to Y9, and now I can see that when I arrow down, the variables have changed, and therefore I'm ready to do money problems. Okay? And we did those yesterday, so you should be okay with those. Please bring any questions about the solver, half-life problems, or money problems with you to class on Monday, and we'll address them then. Have a great day.